Hello guys and welcome to another GD&T related video. So in this video we'll be talking about 3-2-1 principle. The 3-2-1 principle is a fundamental principle in GD&T and which governs how parts are located and clamped in manufacturing and quality inspection. So a very fundamental concept in manufacturing, in design, manufacturing and quality inspection is the concept of degrees of freedom. So any component, any workpiece, any part in space has 6 degrees of freedom. It can move forward and back, it can move up and down, it can move left and right, or it can rotate about the longitudinal axis, it can rotate about the transverse axis, or it can rotate about the lateral axis. So it can rotate about 3 axes, it can move in 3 axes. So it can move forward and back, it can move left and right, it can move up and down, it can roll, that is rotating about the forward and back axis, it can pitch, that is rotating about the left and right axis, it can yaw, that is rotating about the up and down axis. In engineering terms, when we convert these to engineering terms, we can say it is translation in x-axis. If we are having a xyz coordinate system, translation in x-axis, translation in y-axis, which is left and right, translation in z-axis, which is up and down, rotation about x-axis, which is roll, rotation about y-axis, which is pitch, rotation about z-axis, which is yaw. So if you take an aeroplane will have 6 degrees of freedom. It can undergo these types of motions. Whereas for a vehicle which is running on a ground, the certain degrees of freedoms are being constrained because it is running on a ground. And it does not have all of the degrees of freedom. It has a limited number of degrees of freedom. In manufacturing and quality inspection of components, this is a fundamental concept. So any part which has to be manufactured from a block, let's say for example in machining, if you want to machine a part, you need to clamp that component and clamp it and constrain its degrees of freedom. You need to constrain its degrees of freedom and clamp it and locate it and then perform the machining operation. Without sufficiently or reliably clamping or constraining its degrees of freedom, you will not be able to perform the manufacturing operation. Similarly, if you are doing a quality inspection, let's say for example, if you are measuring the location of a hole with respect to a certain reference, you need to locate, you need to clamp, or you need to rest the part in a fixed position and then perform the inspection as shown over here. So in this quality inspection, the part is rested based on this bottom surface and the inspection is being performed. So whatever you do in manufacturing and quality inspection, you need to constrain these degrees of freedom in order to perform it reliably. So that brings us to the 3-2-1 principle. It is not only related to GD&T, but it's related to any manufacturing process. In manufacturing, especially in machining processes where the block has to be clamped and located very precisely for the machining operation to take place. So 3-2-1 principle is that for constraining 6 degrees of freedom, you need to first bring one plane of the part in contact with 3 points. So 3 points are brought into contact with one surface of the block as shown. This is a basic rectangular block and one surface is brought into contact with 3 points. 3 points geometrically form a plane. So the primary datum is formed, that is the primary reference plane is formed by 3 points, and that constrains 3 degrees of freedom. Which 3 degrees of freedom does it constrain? It rotates, it constrains the rotation about 2 axes and the translation about the axis perpendicular to the plane. So rotation about this, and this movement. So 3 degrees of freedom are being constrained over here using 3 points which form a plane, and this is the primary datum. Next, 2 points are brought in contact to a plane which is perpendicular to the primary plane, which is this plane. Green color 2 points are brought in contact. This is the secondary datum. This constrains 2 more degrees of freedom. Which 2 degrees of freedom does it constrain? It constrains the rotation about the axis perpendicular to the primary datum. So if you draw an axis perpendicular to the first plane, which is the primary datum, and you try to rotate the part, it will not rotate because of these 2 points. So that degree of freedom is constrained, and another degree of freedom constraint is translation about this axis, that is this line, translation about this line, that is also constrained. 2 degrees of freedom are being constrained. Now total 3 plus 2, 5 degrees of freedom are being constrained. So the only degree of freedom which is available or which is not constrained is movement about this axis. So it can move like this, that is about this axis. So this block can move up and it can move. So that is the third degree of freedom. So that is constrained by bringing into contact with one more point. So this red color point is brought in contact with over here, and that constrains the last degree of freedom, which is translation. So 6 degrees of freedom are constrained using 6 points. 3 points primary datum, that is the primary reference, the primary surface. Secondary surface has 2 points. Tertiary surface has 1 point. So this is the 3-2-1 principle. This is the minimum number of points required to constrain all of the degrees of freedom of a part of a workpiece in space. Now let's take an example drawing of a GD&T part and see how this principle is being applied. So here is a block which is having a central hole, which is shown over here. So the primary datum feature is this bottom surface. This is the primary datum feature A. Secondary datum feature is the feature of size, which is the width of this block, which is 17 plus or minus 0.2. And tertiary datum feature is is C, which is this one. So 3-2-1 principle applies, and this position control is being applied to this hole as shown. So position of this hole should be within a cylindrical tolerance zone of 0.2 with respect to datum A, B, C. So what exactly is being done over here? When we are checking the location of this hole, we are constraining this block. So in quality inspection, we are constraining this block with respect to its 6 degrees of freedom using the primary datum feature A, secondary datum feature B, and tertiary datum feature C. So first the block will be brought into contact with this bottom surface, the datum feature simulator corresponding to this bottom surface, which is the datum feature A. That will constrain 3 degrees of freedom. Then it will be brought into contact with respect to this width. That will constrain 2 more degrees of freedom. And then it will be brought into contact with the end face, which is datum feature C, that will constrain 1 more degree of freedom. That way 6 degrees of freedom will be constrained in the quality inspection of this part, and then the position of the hole will be measured with respect to the datum references. So again, this block is constrained in 3 steps with respect to its 6 degrees of freedom. First, it's brought into contact with the bottom surface, that is datum feature A, that constrains 3 degrees of freedom. Then it is brought into contact with this width, that is we have a corresponding width which controls or which constrains it over here, something like this. So basically it will have something like this. This will be a gauge block which will come into contact with respect to datum feature A, and that will be of course variable based on this width. And then this C will be brought into contact with a block over here, so end block. So this is primary datum feature simulator for A, for B, and this is for C. This way 3-to-1 principle is being applied, and then the position of this hole is being checked. If you are liking this type of content, be sure to check out the GD&T ebook, which I have in the description below as a link. You can check that out. It has all of the slides of this video as well as many other concepts which are explained in GD&T in that ebook. It will be very helpful reference for you if you are working as a design engineer. So now again back to the video. Here are some commonly asked questions which come up when understanding 3-to-1 principle. Why is it only 3-to-1? Why not more contact points? So 3-to-1 is the ideal minimum. Very important is this ideal minimum. It is the ideal minimum. You can have more than 3-to-1 contact points for constraining the degrees of freedom, but 3-to-1 is the ideal minimum, and hence based on that the principle is established. Generally, if you have more than 3-to-1 points, that adds redundancy It constrains the degrees of freedom, but if you add 4 points instead of 3, you add redundancy. For example, if you take the example of a stool which is having 3 legs is perfectly constrained as opposed to a stool which is having 4 legs. A stool which is having 4 legs, because of the manufacturing variations, will cause rocking, whereas a stool which is having 3 legs will not cause rocking. So their redundancy is being added. So that is what redundancy means. Of course, it does not mean that always you need to have 3 points and 2 points and 1 point. This is the ideal. If possible, we need to make sure that we have 3 to 1 points, which make sure that the part is located precisely. If you have more points, then the precision of location will be affected, redundancy will be added. That is what it means. Why not 2, 3, 1? Why don't we contact 2 points, then 3 points, then 1 point? So when we contact 2 points, we are constraining only 2 degrees of freedom. That creates instability. Hence, this is the reason why primary datum features should always be the most stable one. There should at least be 3 points of contact which are spaced away from each other to give stability. Static equilibrium is very important condition for the primary datum feature. 2 points of contact create instability. It can move, it can rotate in 2 directions. So the first datum feature should always be the most stable one. For quality inspection, this is very important, because if you don't have the primary datum feature which is stable, the inspection is unreliable. It's not precise at all, because the part can move, it can rotate. Here is an example drawing of this part shown over here, in which 3 to 1 principle is applied very precisely using datum targets. So this is the drawing of this part. So these are the 2 views, and you can see over here that the primary datum feature is being represented by datum targets. So if you see the primary datum feature, datum targets, these are the datum targets for the primary datum feature. A1, this is a point. It indicates a point in this view, and X in this view indicates a point. So this is point number 1. Point number 2 is A2. Point number 3 is A3. So you can see there are 3 points which are referencing the primary datum feature. So since this part, datum targets are generally used for parts which are big, and generally we do not rest the complete part onto a surface or a datum feature simulator. Instead, we rest it onto points which are representing the datum feature. So here these points are represented as datum targets as shown, A1, A2 and A3. Then if you see in this view, there are 2 X's at the end in blue color. These are datum targets for B1 and B2, which represent the secondary datum feature, which is B. Secondary datum feature B is represented over here. So basically you can see that instead of placing the part on its side, which is a general procedure in GD&T, we are using points or line contact in this case. So there is a line contact. So in this view, you can see there is a blue color hash line which indicates a line contact datum target. Here is X and here is a line. So line contact datum target, we are constraining the degree of freedom in this direction. That is, movement in this direction is being controlled. The movement in this direction is being controlled by these 2 points and these 2 lines in this view. And then finally, one more point is required to move to constrain the degree of freedom in this direction, which is the final degree of freedom which needs to be constrained, which is this point. This is the C1 point, which indicates for the datum feature C. So you can see over here in the normal GD&T drawings where we do not have datum targets and where the surfaces are not that complex, we have planar features which are representing datum features. But here these surfaces are these points of contact or lines of contact are representing the datum feature. So basically they are constraining the degrees of freedom in various directions using points of contact and line of contact. And based on that, the position of this hole is being measured, which is shown over here. The position of this hole within a cylindrical triangle point 2 with respect to datum ABC, and ABC is being constrained using these datum targets. When the position of this hole is being inspected, this is how the part will be inspected. So it will be rested on 3 points as shown over here. 1, 2, 3 pins which contact at 3 points, which are A1, A2, A3, and then it will be brought into contact with 2 rods as shown over here, 2 posts which will be having line contact, which is B1 and B2. That will constrain 2 more degrees of freedom. Then finally the green color pin will be brought into contact, which will be C1, that is considering the last degree of freedom. So this is precisely applying the 3-2-1 principle. 3 for primary datum feature, 2 for secondary datum feature, and 1 for tertiary datum feature. 3-2-1 principle.